Find the derivative of y equals 3x minus 4 to the 7th times 4x minus 2 to the 5th, then evaluate y prime of 1. Y here is the product of two functions, a 3x minus 4 to the 7th and a 4x minus 2 to the 5th. We will therefore make use of the product rule for the derivative, y prime or dy dx. We will start with the derivative of the first. The first is a quantity raised to the 7th power. We'll start with the 7th power, bring down the power, subtract 1 from it, multiply by the derivative of the inside to complete the chain rule. That'll be a 3. That's all the derivative of the first. Multiply by the second left alone, plus the first left alone, and then the derivative of the second. It will be a power rule. Bring down the 5, subtract 1 from the power, and then multiply by the derivative of the inside to complete the chain rule. This expression can now be factored. There is a common factor of 3x minus 4. We have a 6th power and a 7th power. We can factor out the lower number, which is the 6th power. And then a 4x minus 2. We have a 5th power and a 4th power. We can factor out the lowest number, which is the 4th power. So y prime or dy dx will equal, let's start with factoring out the 3x minus 4 to the power of 6. Now for the first expression, that will take out all 6 of these. There's what's left behind. A 7, a 3, and a 4x minus 2 to the 5th. For the second expression, it's going to take out 6 of the 7 power, so it will remove 6 of those, leaving 1 behind. And there's what's left for that one. So we'll have a 3x minus 4 to the first power. We'll have a 5. We'll have a 4x minus 2 to the 4th, and we'll have the 4. Our next step, we can take out the lower power of the 4x minus 2s. We can take out 4 of those. So we will have 3x minus 4 to the 6th, and a 4x minus 2 to the 4th. Now if we remove those from the first one, we'll take out 4 of the 5. That'll leave just 1 of them. And then for the second expression, it's going to remove all of them. So it looks like we'll have a 7, a 3, a 4x minus 2, plus, and we will have a 3x minus 4, a 5, and a 4. So now y prime, or dy dx, is 3x minus 4 to the 6th times 4x minus 2 to the 4th times, that will distribute the 7 times the 3, which is 21, into the 4x minus 2, and then the 5 times 4, which is a 20. I'll just write it first here, into the 3x minus 4. So we have 3x minus 4 to the 6th, 4x minus 2 to the 4th. Distributing 21 in, that'll give us 84x minus 42. Distributing the 20 in, that will give us 60x minus 80. So y prime, or dy dx, will equal to 3x minus 4 to the 6th times 4x minus 2 to the 4th times, and then we can add like terms together. The 84 and the 60 can add to 144x, and then minus a 42 minus an 80 will be minus 122. It's always possible to factor a common factor out of there, and it looks like we can factor out a 2. And we'll move that 2 to the very front. So we'll have a 2 times a 3x minus 4 to the 6th times a 4x minus 2 to the 4th. And if we factor a 2 out of that, that's going to leave us with a 72x minus a 61. So there's the derivative fully factored. The next step is to evaluate y prime of 1. So y prime of 1 means to plug a 1 in for each of the x's. We will have 2 times 3 times 1 minus 4 to the 6th power times 4 times 1 minus 2 to the 4th power times a 72 times 1 minus a 61. So we will have 2 times 3 minus 4, which is a negative 1 to the 6th power. 4 minus 2, which is 2 to the 4th power. And then 72 minus 61, which is 11. So this will be 2 times negative 1 to the 6th power is a positive 1. It's an even number of them. 2 to the 4th power, 2 multiplied times itself 4 times will be a 16. And then 11. 2 times 16 is 32 times that 1 will still be a 32. And so we end up with 32 times 11, which is 352.